Okay, so let's take a look at the homework questions on page 553. Okay, the ones that you're going to work on today. Okay, so only watch this after you've worked on them today. So number 9 says alpha particle has a mass of 6.6 times 10 to the 27th kilograms. It says it's doubly ionized, which means it's 2 times the charge of 1 electron. Tells us that its magnetic field is 2 teslas and that it has a radius of 0.15 meters and it wants the velocity. So we're going to use R is equal to mv over qb and we're going to rearrange for v. And then we're going to fill our R in, so 0.15 meters. Our Q multiply by the 2, so 3.204 to the negative 19 coulombs. And the B, which was 2 teslas. And then you're going to divide by the 6.6 times 10 to the negative 27 kilograms. You're going to punch all of that into your calculator, and when you do, you should get 1.456 times 10 to the 7th meters per second. That's part A. Part B then wants to know what is its kinetic energy. So to do its kinetic energy, you will just do EK is equal to a half mv squared. So 1/2 6.6 to the negative 27 kilograms. And then the speed that you just had, 1.456 to the 7th meters per second, and that gets squared. Punch that in your calculator, and you should get 6.9993 times 10 to the negative 13 joules. Okay, that's part B. Part C wants what potential difference would be required to give it this kinetic energy. So we know potential difference is equal to EK over Q. So that's 6.9993 that you just found, and you're going to divide it by the charge doubly ionized 3.204 to the negative 19 coulombs. Punch that into your calculator and get 2.1845 times 10 to the 6 volts. Okay, so that's it for number 9. It was starred or diamond or whatever, I think, because of these two parts. Number 10 is actually easier. Number 10 gives us a magnetic field, 3 to the negative 2, gives us a radius, tells us that it's an isotope of sodium, and in mass spectrometer, single positive charge, 1.602, its speed is 1 to the 4th, and it wants the mass. So again, rearrange the R equals mv over qb for m, fill in all your numbers, punch them in, and you should get 3.89286 times 10 to the negative 26 kilograms. All right, the next one is potentially the toughest. Really, it should have been starred instead of number 9, because number 9, they walked you through the steps. Number 11, they don't. So in 11, they tell us an alpha particle, slightly more mass than the one above. The one above was 6.6, this is 6.7. Tells us that the potential difference is 1,000 volts, 1 kilovolt. It says that the magnetic field strength is 6.5 to the negative 2 teslas, and that it's doubly ionized again, so again 2 times 1.6, and it wants the radius. So we know R is equal to mv over qb. But be awake here, be alert. This v is a tiny v. It is velocity. This v is a large v. It is voltage. Even if you make this v tiny, you still cannot put it in over here. You should be laughing at this point, but I always have people who just write this as a smaller v and then they stick 1,000 in here. Does not work. So you need to find the voltage. So up here, they gave us all the stuff. We found the velocity. We used the velocity to find the energy. We used the energy to find the voltage. That was in question 9. In question 11, gave us the voltage. We can find the energy. With the energy, we can find the velocity. and with the velocity we can find the radius. So we're just going to go backwards. Okay, so we're going to start with knowing that v is equal to ek over q, which means ek is equal to q times v. So ek is equal to that 3.204 to the negative 19 coulombs times 1,000 volts. When you do that, you get an ek of 3.204 to the negative 16 joules. Then we know ek is equal to 1/2 mv squared. So that means v squared will be equal to 2 ek over m. So we take our 3.204 to the negative 16 joules, and we divide it by our 6, multiply it by 2, would be a good thing, and then divide it by 6.7 this time to the negative 27 kilograms. That'll be v squared. Don't forget to take the square root. And when you do, you get 3.0926 times 10 to the 5th meters per second. Once we have that, we can come back over here and fill everything in for r. So 6.7 times 10 to the negative 27 kilograms, 3.0926 to the 7th meters per second. On the bottom, 3.204 to the negative 19 coulombs, and our field was 6.5 to the negative 2 teslas. Punch all of that in, and you should get a radius of 9.9493 to the negative 2 meters. Okay, so in number 9, they walked you through the steps to make the connection, and then in number 11, they assumed you would know. So you start, use the voltage to find the kinetic energy. Oops. Use the kinetic energy to find the velocity, and then use that velocity to get your radius. Okay? So the good news is number 12 is exactly the same, except this time it's an electron, so its charge is 1.602. We know its mass is 9.1 to the negative 31. We know its it tells us the voltage is 4,500 volts, and this time it tells us the radius, and you have to find the b. So again, you're going to use the voltage to get the kinetic energy, you're going to use the kinetic energy to get the velocity, and then when you get the velocity, come back to r equals mv over qb. Okay, so I want you to try number 12 and number 13 because it's identical on your own. I'd be okay if you skipped 14 just because it is a little weird. You could do it with ratios, or if you want a challenge, you could try it. But if you can do 12 and 13 as practice of this new technique, of this extra steps, I will be happy. Second video will be on something new. Please watch it, and we'll see you tomorrow.